93 million miles away, this middle-aged yellow dwarf star. It's the Sun, the super source of power for our solar system. Our star produces enormous amounts of heat and energy. In 1 second, the Sun churns out more energy than has been used in all of human civilization. It has shone for 5 billion years and will shine for 5 billion more. It is so central to life that we often don't give it a second thought. For us, it's the great engine of life. So how does this star that dominates our cosmic neighborhood generate so much energy? The Sun is an infernal sphere of mostly hydrogen and helium. Hydrogen atoms are smashed together at a high rate of speed and fuse to form helium atoms. Mass is converted to energy in quantity measured by E equals mc squared.
It followed from the special theory of relativity that mass and energy are but different manifestations of the same thing. Furthermore, the equation E is equal mc squared, in which energy is but equal to mass multiplied with the square of the velocity of light, showed that very small amount of mass may be converted into a very large amount of energy.
Coal powers the world. However, the use of coal in energy production can cause problems. Coal burning produces acid rain, sulfur oxide emission, and carbon dioxide emissions. We depend on oil for 90% of our transportation fuel, as well as for food, pharmaceuticals, and chemicals. In many ways, oil is the backbone of modern life, but the tank is starting to run dry. Some oil industry experts estimate that current reserves will only last for about another 40 years. If everyone in developing countries were to begin using the same amount of energy as the average consumer in high-income countries do now, energy use would increase more than 8-fold by 2050. What about nuclear power? Current nuclear power plants, which use fission, or the splitting of atoms to produce energy, have been in use for 2 generations and will be needed to bridge the gap between now and the fusion future. Replicating the extreme conditions that foster the fusion process under controlled conditions has been one of the most demanding scientific challenges of the last half-century. When NIF is completed at Lawrence Livermore National Laboratory in 2009, that long scientific quest will be much closer to
Shot director, ready for shot. Starting countdown for shot on my mark. 3, 2, 1, mark. Clock is running. 5, 4, 3, 2, 1, shot.